So students, very good morning to you all. And today we are going to discuss one of the important topic, and the topic is, yes, and the topic is sequencing problem. I am your instructor, Dr. Ritesh Singhal, and this topic is specifically designed for MBA program semester 2, and the subject is quantitative techniques for managers. Now let's start the topic sequencing problem here. Okay, so students, sequencing means, the term sequencing means that when you are uh, going to arrange some jobs in some meaningful sequence, so that the total time taken by all the jobs is to be minimum. So here sequencing means the same meaning, that whenever we make some sequence of the odd jobs given to us, and our objective is to find this optimal sequence where all the jobs is to be completed within a minimum time. So sequencing problem arises where there is a choice as to the order in which the number of tasks can be performed. So whenever you have a choice, and then in that case, this optimal sequence will give you an arrangement of jobs so that your total time taken is to be minimum. In such cases, the effectiveness is a function of sequence in which the tasks are performed. So in such cases, effectiveness is a function. So we need to effectively complete all the jobs within minimum time. So that is why we are going to find the optimal sequence here. For example, there are a number of examples, including jobs in manufacturing plants, maintenance scheduling in a factory, and etc. So there are a number of examples that can be used in case of with sequencing problem. So let's move further. One important or basic method or rule or algorithm that we are going to use here is called Johnson's algorithm. Johnson's algorithm. This is the single method, or you can say one of the important method of solving sequencing problems. Here, the Johnson's rule says that a procedure that minimizes the time taken when scheduling a group of jobs on two workstations. Okay, so this procedure, it is a procedure that minimizes the time taken when scheduling of a group of jobs on two workstations. That may be more than two also sometime. Now, what are the steps? Step 1, find the shortest processing time among the jobs not yet scheduled, and if two or more jobs are having the same minimum time, or that you can say these are tied. So in that case, choose any one arbitrarily. So whenever you are going to find some minimum time, and minimum time is not unique, so in that case you can find any one time that is available to us. Second step is, if the shortest processing time is on workstation 1, suppose the shortest processing time is on workstation 1, so schedule this corresponding job as early as possible. As early as possible. When the minimum or the shortest time is available on workstation 1 or machine 1. Similarly, if the shortest processing time is on machine 2, then schedule this corresponding job as late as possible. Okay, so remember these two things in your mind, that minimum time is available with which machine, either machine 1 or machine 2. If it is in machine 1, then schedule this corresponding task as early as possible, and if it is machine 2, then schedule this job as late as possible. Eliminate that particular job that is being scheduled and find the remaining jobs and do the same exercise for all remaining jobs, and repeat these steps 1 and 2 until all the jobs have been scheduled. So repeat this procedure, step 1, 2, 3, and repeat this procedure whenever you have all the jobs exhausted, and this is called Johnson's algorithm. So dear, we are going to solve a particular example. We are going to take one example here and try to solve that example using Johnson's rule. So let's start. Yes, suppose there are 5 jobs given to us. There are 5 jobs given to us, and here the timings that required a job to complete on workstation 1, machine 1 and machine 2 is given in terms of hours here. For example, job J1 requires 12 hours on machine 1 and 22 hours on machine 2. Similarly, all the jobs are having some specific requirement on machine 1 and machine 2. These are nothing but times in hour. So now first step is to find out the optimal sequence of jobs. Whether we are going to complete these jobs in these same order, J1, J2, J3, J5, or there is some another order. Okay, so let's use Johnson's algorithm here and see how the things are going to be completed here. I remove all the notations and going to write these things. So number 1, find out the minimum time in both the machines. Yes, the minimum time is 3. And we have seen in Johnson's algorithm that if minimum time is on machine 2, then schedule this job as late as possible. So schedule this job J3 as late as possible. And third step, eliminate this job that is being already scheduled, so that we cannot, or we by mistake we cannot schedule it again and again. Now find the minimum time on the remaining matrix, and we found that the next minimum is 4. And this 4 is on machine 1. That is why we are going to schedule this job J2 at early as possible. So we'll complete this job at the first stage, at very first moment. Third minimum is 8. And this 8 is on machine 2. That is why we are going to schedule this J5 as late as possible. Next minimum is 12. Next minimum is 12. Schedule this J1 as early as possible. Now we are only having the one single option, that is J4. And now this sequence is ready. And this sequence is optimal sequence where you can find that all the jobs are being completed within minimum time. So this is the first part of the question, to find the optimal sequence. And this is the sequence. So students, it is advised, if you have these 5 jobs to complete, so it is advised to you that complete these jobs in these sequence, like J1, J2, J1, J4, J5, and then at the end J3. Now we are going to see how much time is required if we are going to solve, if we are going to do these jobs in this optimal sequence. So let's see how this thing is to be done here. Yes, this is one of the animated kind of thing. Yes. So next thing is processing time. These are the optimal sequence which we just find here. Optimal sequence of jobs J2, J1, 4, 5 and 3. And this is nothing but time required in machine A, and this is time required in machine B. Okay. For each machine we have 3 further columns, like first is in, second is out, and third one is reserved for idle time. Here we are going to find idle time. Idle time for machine A, obviously, and then here idle time for machine B. And I think you know what is idle time. Idle time is nothing but the time where machine has no jobs to do. It means machine is not doing anything. Yes. Now we are going to complete this table. This table is called processing time table. Here we are actually going to find out how much time is required to complete all the jobs. So let's start. Students, please keep in your mind always that you should start with 0. When your stopwatch is showing 0, then you should start. Your time starts now. So when you enter this particular job, J2, into machine A, at very first beginning time, it requires 4 hours. So it will be out at 4th hour. And similarly, after completion of by A, you have to enter this job on B at 4th hour. It requires 5 hours to complete. So 4 plus 5, 9. So at the 9th hour, it is going to be out from machine B. Now, the second job is J1. You should start this job as and when machine is free, that is on 4th hour. It requires 12 hours. So 4 plus 12 is 16. Now, when this job J1 is entered into machine B, you should start at 16th hour. It requires 22 hours. So the out time would be 38 hours. So when your watch showing 38th hour, job J1 will be out from machine B. Now the third job J4. It is to be started at 16th hour on machine A, requiring 15 hours. So 16 plus 15 is 31. So the end time would be 31. Now this job is to be entered into machine B. But see carefully, since machine B is not free, machine B is engaged in the previous job. So this job J4 has to wait outside, and it is only to be entered into the machine whenever your clock showing 38th hour. It means you can only start a particular job when the job and machine both are ready to function. That is, you can remember it like this. Whenever these two values, these two box values are showing here, write the maximum value here. Okay, it requires, now the job J4 is entered at 38th hour. It requires 16 hours. So the end time would be 54th hour. Similarly, job J5 is to be entered at 31st hour. The completion time would be 41, 31 plus 10. And now in the same manner, you should start J5 on machine B at 54th hour. It requires 8 hours, so end time would be 62 hours. Similarly, the last one, J3, it is to be entered at 41. It requiring 5 hours to complete. So 41 plus 5, 41 plus 5, yes, it is there. 41 plus 5, that is 46. Now it is to be entered here at 62th time, requiring 3 hours. So the completion time is 65 hours. So student, you can see here that, yes, so you can see here that all the jobs is to be completed when your clock showing 65 hours. So 65 hours are requiring to complete all the jobs, and this is the minimum time requiring to complete all the jobs. This time is called total elapsed time. Elapsed time. Okay, so 65 hours is total elapsed time. So now the next step is to find the idle time for machine A as well as for machine B. I told you earlier that idle time is the time whenever machine is doing nothing. So see, at the end of machine A, you are going to start at 1, then 4, completed 16, 31, 31, 41, 46. So from 0 to 46, For 0 to 46, there is no idle time. From 0 to 46, there is no idle time. Dash, dash. So there is no idle time from 14 to 0 to 46. Now let's see on machine B. Student, keep one thing in your mind, that idle time is to be calculated from this time to this time. That is from 0 to 65. Beyond 65 and before 0, we are not responsible for any idle time. But yes, from 0 to 65, we should be taken care of the idle time for machine A and B both. For machine B, the first job is to be started at 4th hour. So starting 4 hours are the idle time for machine B. After that, this is a gap of 7 hours. There is no gap. There is again no gap. There is again no gap. So the total idle time for machine B is 11 hours. Okay. But for machine A, there is one more gap, that machine A completed all their jobs at 46th time, 46th hour, but he has to wait for machine B to complete the entire project. So the difference between 46 and 65, that is 19 hour, this is called the idle time for machine A. Idle time for machine A. From 0 to 46, there is no idle time, definitely. But after 46, machine A has to wait for machine B, because the entire project is only finished when all the jobs is to be completed on both the machines. So students, number one thing, find the sequence, optimal sequence. Next thing is find the total elapsed time here, like 46. And the third thing is find the idle time for machine A and machine B. Okay, so I hope you understand this particular problem. There are few more problems I have taken today, like this. Here there are 6 jobs. There are 6 jobs to perform, and there are 2 machines, machine A and machine B. So see how we find the optimal sequence. Draw 6 blanks spaces to fill. 6 blank spaces to fill. Find the minimum out of these machines. The minimum one is here 1. Do this job 6 at the end. Next minimum is 2 definitely. It is on machine 1. That is why you should start this job as early as possible. Next minimum is 3. You should do this job as late as possible. Next minimum is 4. You should do this job as early as possible. Then next minimum is again 4. Do this job as late as possible, and the remaining job, that is 4th, you should do at this place. So this is the optimal sequence here: 3, 2, 4, 5, 1, 6. So it is advised, students, this is an exercise. You complete this table, and you will find that the total elapsed time and the idle time for both the machine can be calculated using this optimal sequence. Okay, so students, I think you understood this session, and we'll meet in next video for few more topics of operation research and quantitative techniques. This is your instructor, Dr. Hitesh Singhal, and wants to seek your permission to close this video, and we'll meet in next class. Thank you, goodbye, and take care.